Today's an exciting day in the development of SCION. If you haven't been following the project for the last year, SCION is a device that I've been working on to make it super easy to use analog devices as basically an effects send chain for high quality digital video. Watch previous videos, watch future upcoming videos to learn more about it. Today's an exciting day because I am moving away soon from using a prototype board to a more fully developed board that'll be the basis for the actual product. So up until this point, I've been using this bodged together board here to do all the development of the firmware and the client application for SCION. It's based around this blue board here, which is an evaluation board for the ASIC chip here. This is a special ASIC coming out of Asia that is designed to do all the things you'd expect from a high quality video mixer: format conversion, scaling, rotation, color correction, and it's all in this little chip here. It comes on this blue board here, which is the evaluation board, and I've bodged that board significantly. It came with its own sort of low power STM microcontroller I've had to remove. I've replaced it with what's on these two daughter boards here. This daughter board here has a new STM32 analog to digital converter and two DACs over here. The evaluation board, I don't know if you can see it in the video here, has a bunch of HDMI inputs and outputs, and my daughter boards add the analog inputs and outputs. And this has worked well. This has allowed me to get really far, but it's getting pretty frustrating to use. You can see there are some bodge wires here, and there's a lot of bodging happening on the board under there, and it's getting pretty fragile. It uses these little Samtech edge connectors here. I'm out of focus, there we go. These are rated of like 2 connection cycles, and as you can tell by the fact that I've got multiple of these daughter boards, they've been connected and disconnected a bunch, and I'm getting signal integrity issues with the high-speed digital signaling that's going between the ASIC and my daughter boards. So today we've sent off for manufacturing. Let me share my screen. This guy here, which is hopefully pretty close to the finished product. We have the digital video connectors back here. Up the front, it connects to a front panel, which will have the analog interfaces. The ASIC goes here. You'll notice there's a bunch of these 1.54 millimeter connectors. That's for debugging. If this board works, we can just remove them and leave them as people can plug their own ones in if they want to hack on the internals. But this is exciting. This is all on one board. A lot of the concerns that we've had about signal integrity should be resolved by this board. It has a lot more functionality. We've got an additional DAC channel here and the same single ADC here. And it's been a long journey to get here, and I have not done it alone. I've done it with Max Hunter, who's the electronics engineer who's been working on this board for me. And so I want to spend some time today chatting with Max to learn a little bit more about his background and to talk more about this board. So let's get over to Max. All right, Max, how are you doing?
Good. How are you?
I'm doing well. I'm very excited. Anyway, before we dive in, I think it'd be good to go through. I don't actually know a ton of your background, but maybe you want to give a little potted history of Max Hunter.
Yeah, it's been a bit of a portfolio career in some ways. I started off as an undergraduate in physics at Imperial in London, and then I was a neuroscientist for a few years at University College in London. And then I had a quarter life crisis and realized that I wanted to be a touring sound engineer. So I spent a lot of time on the road doing arena shows, festivals, stadiums, theaters, that whole thing. And weirdly, there was quite a lot of overlap in the academia to human perception and everything. That you're basically trying to fool people into believing what's on stage. So that kind of led me back to doing more design-based things for that world. A lot of my work is in audio, but across the whole kind of audio-visual side of things, building weird tools to make live shows more exciting.
Did you do a lot of electronics as part of your undergraduate degree or as part of your degree?
Yeah, we did actually. We did. I mean, we ended up doing, there was an electrical engineering degree at the same
Okay,
time that was run by a different department, and they tended to do sort of more applied things. We sort of ended up figuring out how transistors were built, but we did quite a lot of assembly programming. The course was kind of based back in the 70s or something, so there was a lot of
right.
kind of writing step-by-step logic and building your own little flip-flop gates to build a bit of RAM or a byte of RAM and building little things that switched on and off from there. So in a lot of ways, I think that's given me quite a nice grounding, pun not intended,
Right.
in for the electronic side of things. I mean, so much of it is at this point to do with sort of signal integrity and how waves travel through PCB materials and how dielectric propagation and whatever. And I think actually the physics has kind of come full circle. I
Right.
just wish I'd paid more attention in lectures at the time, but
How did you actually make the jump from neuroscience to the audio world?
weirdly sort of got a bit disillusioned with academia for a bit. And I was thinking of doing a PhD at MIT in the Media Lab in sort of weird new instruments and modes of creative expression. So
Yep.
they're a really interesting team there, and they basically are trying to push the boundaries of live performance and all sorts of things. And then I got this offer to go to China for 4 months and tour with an a cappella group. And I sort of thought, okay, well, this is the time. Either I throw the towel in now, or
Right.
I stay going on with a PhD. And I, at the time, I was sort of 2 years off finishing a PhD, and I sort of thought, okay, well, the
What was
the
your
only
PhD
advantage
in?
at this point. The PhD
Oh,
was in spike sorting for neuroscience data. So I still have sort of one foot in that world, doing a lot
right.
of experiments. So designing hardware for neuroscience experiments. Um, and I was kind of doing a lot of the data analysis side of the thing. So I was designing pipelines for to process petabytes of data from mouse brains
Hmm.
and make use of them. And we were actually doing a whole bunch of stuff with FPGAs, and we developed a custom bit of silicon with a team at IMEC, which I was trying to get all of the software side working for, but they were building basically a custom ASIC
Mm.
with I think there were 500 ADCs on the actual bit of silicon that would go into a mouse brain
Hmm.
and would be able to kind of collect data and kind of stream it at gigabits per second to the computer. So it's yeah, we were pushing the edges of those kinds of things without really realizing at the time, but that's kind of coming quite useful 10 years later.
But so we could talk about medical stuff for a while, but um, a cappella. So when I think of a cappella, I think of no microphones, no speakers, no projections. I think of, a quiet group, in a church.
Yeah,
That's where a
I
cappella
think
comes
that's,
from,
I mean,
right?
a cappella, that's the original, that's that in translations of it,
Right,
a cappella and in the church or of the church,
right.
um, at
So you
least
were
on the
singing
periphery
as
of it.
well,
Oh,
or
I
both?
came in as a singer.
Oh, wow, okay,
I spent most of my teenage years singing services a week, several services a week in the church,
okay,
doing, choral music and stuff. And then discovered jazz and discovered that whole world, and then yeah, came to the sort of audio engineering side of it.
right.
Actually, from a kind of realization that most of the audio engineering I was hearing is pretty terrible, and I thought I could do it better. And we
Hmm.
were kind of going on tour, and we sounded terrible. And I ended up beatboxing from behind the sound desk a bunch of times in my early 20s.
Right.
And then I said, okay, well, maybe I actually prefer being behind the stage than on it.
You've been working now on electronics products that really sort of focus on audio primarily. Is that correct?
Yeah, that's been most of my focus. I mean, I started out as an audio engineer, and so a lot of it was born out of frustration from the amount of tooling that there was in the electronics in the audio world. There's a
Mm.
lot of, a lot of the mixing desks and all of that kind of stuff are still pretty much based on studio consoles from the 1960s. And the tech has developed so much since then in terms of what we're able to do, and yet people are still there lugging around trucks full of copper to plug individual microphones in
Hmm.
when we've now got, much faster network-based audio protocols and things. So there's a lot of kind of bits of tooling which are, not very flashy, but all the nuts and bolts to actually get things in and out of the right place. I think is some of the coolest bits in a lot of ways.
We met through my friend Luke, who's a very, very competent programmer and very, very competent musician, who decided to jump into the electronic space building sort of a unique bit of kit for use in studios. Using sort of the Dante and other audio over IP protocols. And he first turned to me and then got beyond my level of skills with electronics and then came to you to help get that project over the line. And that's using sort of Dante and those audio over Ethernet things, which I think are getting to what you were talking about, which is moving away from lots of analog copper pairs carrying signals around to moving to Ethernet and IP-based solutions.
Yeah, no, I think Luke has been doing exactly that. It's kind of very much in my wheelhouse. His project, which he's posted about on his LinkedIn, is to have a monitor mixer so that musicians can hear can change what they can hear, and as a result of that, there are dozens and dozens of channels being streamed over a single network connection that also provides power, and so you can kind of plug this in on stage and turn your mix up and down from anywhere and recall it from a central place. And it's kind of those little usability things that make a huge difference in the life of musicians. And there's so much of this stuff like doesn't really exist in a way that's easy to configure and easy to set up and robust. Survives power spikes, survives being dropped on the ground. A lot of people designing equipment, I think, don't ever use the equipment. Like they're not the
Right.
target market. And so I find this with a lot of pro audio gear, that it's kind of been designed in a way that sort of seems to make sense conceptually, but doesn't respond to the needs of actual users. So it's kind of fun being working with Luke and who actually is the target market for his own product. He wanted to
Hmm.
build originally, I think, one for himself and one for a friend, and it then got convinced to build five and now 10 or 50. But it was
Right.
originally a project for his own needs, which I think was quite a fun concept.
Not only does it sort of make the studio world better, or at least the production world better when you can have everything over Ethernet in terms of just the amount of copper you have to carry around, it seems to also enable other things. I'm trying to sort of segue neatly into your Wayfield stuff because
Mm.
my understanding of that project is pretty high level, but it involves placing hundreds, if not thousands potentially of audio sources, and that is not really possible if you're running that much copper.
Yeah, totally. I mean, I sort of spent a lot of my career doing, I guess, weird projects that push the boundaries of what's possible with tech.
Right.
And that has kind of ended up, I've ended up sort of having a speciality in doing very high channel count projects. And
Hmm.
that sort of came a little bit from the neuroscience world where we were kind of trying to record as many neurons as possible. And these ADCs were recording 32 kilohertz spike train data from
Hmm.
brain cells, and we were recording 1,000 of them at a time. And that was kind of just what we were doing at the time, back in 2010. And now people are sort of going, okay, well, we'd like to have more than 30 channels or more than 60 channels, but that's a lot of data.
Hmm.
And actually, we were doing this 10 years ago. So taking a lot of stuff from that world, I've been trying to play around with the idea of having thousands and thousands of speakers set up, and using constructive and destructive interference to produce these kind of sound fields within a room.
Hmm.
Um, I've been working on this with a colleague, Dan Jones, and we've been kind of developing some prototypes that use network audio, to achieve kind of nanosecond level synchronization between lots and lots of different speakers, so that each one can play slightly different versions of the same sound, and then you get these kind of crazy holograms or acousticgrams or whatever you want to call them, which are kind of floating in the air. So it's really quite cool. And it's tech that's only really got affordable in the past decade. And there's so many kind of low-hanging fruit now, with the level of silicon that we have available,
Hmm.
to try and kind of create these weird experiences, which are a little bit, unusual.
I think I found an interview of you at a theatre in London, where
Yeah.
you're talking about you know smaller channel counts, but still high channel counts from a typical theatre production. This was a play, I believe.
Yeah, I mean that was an interesting one. I think the theater world is kind of one of the places that's pushing the boundary a lot more in terms of not only things like channel count, but kind
Mm,
of live production in video and um, automation and kind of stage magic and all those things. I mean, they have higher budgets, but also they have a lot of time to put on a show in a way that um, you can really finesse something and get it to be the same again and again.
hmm
You go into a festival or an arena or something, the conditions are so variable, everything's a bit different. At that point, it's really about reliability and robustness.
mm.
And then you get into a really controlled setting, so either theater or kind of experiential, immersive stuff where you have
Installations.
yeah, exactly. Yeah. And so it's kind of install slash theater worlds where I think people have the kind of flexibility to really try and, create these experiences.
You said before that you sort of found yourself in a space whereby you do a lot of stuff with high channel counts and helping people sort of push what's possible. I think with SCION, you're helping me push what's reasonable. It's a very weird project, but this is obviously in the video space versus audio. How have you found it sort of working on this project?
Yeah, it's interesting because I mean in the audio world actually there's a lot of people are still sticking with analog, right?
Mm,
There's despite all of the benefits of having ones and zeros which sort of basically don't degrade, are far less susceptible to noise and whatever.
mm,
And a lot of people sort of stick with analog partly because of some perceived audio quality reason, but I think mostly because you have a lot of flexibility to kind of mess with it in a weird musical sense. People have guitar pedals that they're kind of creating these sort of weird warbles and glitches through, and people are kind of have these analog valve compressors, and I mean all of these are designed to destructively interfere with the sound.
mm,
Um, and um, that they're not high fidelity, right? Like the goal as from an engineering point of view is, as I'm always trying to think, well, how do you keep this exactly as this signal exactly as it
right.
was intended with no degradation? But then you realize that all of creative expression really is about creating these kind of weird degradations and messing with stuff. I mean, nobody's doing perfect sine waves. Nobody's kind of watching test patterns for three
Mm,
hours at the cinema. You in the audio world, you kind of like the tape hiss and crackle and noise, and in the video world, people are so attached to grain and distortion and glitching effects and things. I think that was the fun thing with Scion is that in a lot of ways it's all but disappeared
mm,
in the video world. I mean, everyone's moved to digital, whether that's NDI or SMPTE 2110 or SDI or whatever it is, because the advantages are so vast in terms of just being able to transport stuff and push the limits of resolution. So it's kind of fun that we've gone full circle here, and that we're trying to enable. I like to think of it in the same way as vinyl for
yep.
that's seeing a huge resurgence as people want to get more connected to the music that they're making. And I would be surprised if there wasn't a lot of appetite for this kind of thing in the video world as well.
Yeah, I'm just looking over my shelf here of vintage lenses. Because I think what you see in the video world is, as cameras have become, digital cameras have become so good. They've got such great dynamic range, such great resolution. The argument for using film is getting, less and less. And so people, when they're working in a digital environment, want to use something that gives some characteristic or personality or emotion. And so you've got this resurgence in vintage lenses with all their aberrations, everything these days anamorphic everywhere. So you get the barrel distortion at the ends and the streaks, and you can
Mm,
do it all in post. But I think there's a strong argument that any sort of analog effects unit, and this might be pissing off some audiophiles, you can do in digital, but there's
yeah,
something about the serendipity and the permanence and the sort of the one-way doors of working with physical wires versus
yeah,
plugins. You feel like you have to commit to a path. Like clicking a
yeah,
button is a lot less easy than repatching a cable, or trying to remember how
Yeah.
all your wires are set up, and you have to make choices and you have to sort of live with those choices. And so I
Yeah,
think
I think in a lot of ways
yeah,
also kind of constraints breed creativity, right?
yeah,
You have so many tools at your disposal right now. You open up After Effects or whatever, or should it be DaVinci or should it be
right.
Premiere Pro or whatever it is? You're already trying to choose between a billion different options to what to do, and I think people lean on vintage microphones to be able to have a sound that that they like, rather than having a million different options in post to be able to kind of go, oh, maybe this, maybe that. And I think we're drawn to low fidelity in a lot of ways. I think our brain makes up the gaps, and this is kind of true. I find that the videos I come back to again and again, that I watch on YouTube are grainy videos of a concert in the 1980s filmed with a
Mm,
potato.
yeah,
Um, and the audio is all crushed up, and I kind of remember the bit where it kind of glitches out or someone kind of rubs against the camera, and I kind of there's a nostalgia for
yeah,
that. Um, and I keep thinking at the time when people move to HD, um, all of these film sets and everything look too real.
mm.
People, it's not natural. It's not necessary. It's not it's not necessary that we should need to strive for the highest resolution and the highest fidelity in everything we do. I think there's a real joy in getting our brain to fill in the gaps.
Yeah, I think that's been one of the big tensions in sort of this SCION project is I've got these two very competing constraints. One is ultra sort of high fidelity. I want, the signal path to be sort of bit perfect. But at the end, it's going out of an analog interface. And once it sort of leaves the front connector, it's going to lose a lot of that quality. But I don't want there to be any flavor or color sort of imparted by the device itself. So I know I've been really hard on sort of noise floors and bit depths and signal integrity stuff, because I sort of want to put that, because I've got my mixing console here, my audio mixing console. I wish I could put my camera around, but like I send video through that, and that does not pass video well, but it looks cool. But I don't want that color to come from the box itself. I want it to be sort of a flavorless, in some ways visually boring box whereby you
Mm.
send a signal through from HDMI out to analog, then back through to HDMI. I want it to look sort of identical. And I think that's been one of the big challenges, and one of the many reasons I want to move away from this board is that the noise floor and power architecture on here isn't great just because of the nature of the evaluation board that we're using. But what are some of the other challenges been from your perspective in sort of doing this?
Yeah, I think, as you say, we've both agreed that it's got to be this product in particular is a high fidelity thing, and it's kind of enabling a low fidelity world in a lot of ways. And I know that um, your dream is to create a whole kind of ecosystem of degrading pedals, rack mount units, things that enable you to do weird things with it. Right, exactly,
Some of them here.
totally.
Yep.
And I think in the same thing in the audio world, there's places that you do want your audio to be degraded, and there are places where you don't want it, right? Like you want your transport protocol to be bit perfect, and then you want your microphone or your compressor or EQ or whatever to be the thing that's actually doing the degradation, and it's the same thing here, right? That as you say, Scion should be as close to bit perfect as it can,
Mm.
um, so that you can introduce the kind of funky effects elsewhere, and it's not kind of obviously colored by just being through the system. So I think the tricky things that or the challenging things with Scion have been um, actually having the noise floor low enough, with all sorts of high-speed digital signals flying around, so the ADCs and DACs are actually running at hundreds of megahertz, with quite sharp edges, separated by not very much from the analog signals, which again, on a VHS tape, you wouldn't have this level of detail, but because we're blessed with ADCs that have, a really high bit depth, we can record all of these signals. And so I think the challenge has been trying to design the power infrastructure, the power architecture in a way that is good for EMI and good for signal integrity, and keeping the noise floor as low as possible. It's a mixed signal board, and those are the trickiest ones to do always. So, the fact that you've got sensitive analog and high speed digital right next to each other has been a fun challenge.
How do you find that process of doing the layout of the board? Because I know looking at it from me is like there's no way I could even think to approach this.
Yeah, it's the BGA thing is interesting. I think you kind of just have to uh, develop a methodology and just get into it, and be zen about it. It feels like knitting to me in a
Yeah.
lot of ways, where and also the first time that you try and lay something out, it sort of ends up being a horrible mess, and you end up having to rip it up and start again. Um, and with a BGA, with any of these things, there's something quite sort of heuristic about it, where part of it is just going, okay, well, I'm going to root out everything from the first layer first, and then drop down to layer three for the
Mm,
inner pins, and then drop down to layer five as necessary, and kind of having a structure, because it's very easy sometimes to go. Um, uh, to root something, and then it really sort of screws you up a bit later.
mm,
And for those of you who haven't done sort of PCB routing before, if you've ever seen that game where you have to connect dots with different colors, there's a lot of people in the UK playing sort of mobile phone app thing
right.
where you have sort of two red dots, and you have to connect them, and you have two green dots, and you also have to connect them. And of course, if you screw it up, then you can't,
Yeah,
you have
my,
to
my
cross
kids
yourself.
play a game on their iPad, which is like a city, and you have to connect the cities by roads. I'm like, this is just training everyone to become layout engineers.
Totally, yeah. And I think that one of the biggest things to do is it's so easy to root yourself into a corner.
Yeah.
So it's very easy to go, okay, well, this is here, this is the easiest way to route it. But if you route it on the wrong layer, then the following day when you get to route something else, you'll go, oh, I have to cross all of these tracks. I wish I had kind of done this in the first place. And so so there's the old school routing techniques where everything horizontal is on one
Mm,
line and then everything vertical is on the other one, or whatever, and then you end up going through quite a lot of vias to kind of get from A to B. Um, and so there's a kind of hybrid approach here where you kind of have to go, okay, well, start with the high speed signals first, because those are the ones that really matter. Those need no
mm,
vias or as few as possible, and just be really careful about trace spacing and breaking them out symmetrically and accurately. And then power and ground all on the bottom layer. And in this kind of situation, there's been lots and lots of different power rails on board.
mm,
Every single HDMI transmitter has its own separate power rail. So,
mm.
we've got over 20 individual power sort of rails per board per BGA. Um, and so once you've done those, a lot of the lower speed signals, they can jump through loads of hoops. If it's just a
Yeah.
reset pin or even I squared C, which is very low speed in the grand scale of things,
Yeah.
it's pretty much DC. All of those things can jump over, lots of different traces. It doesn't really matter. You can go through 20, 30 vias and I squared C will work absolutely fine, but HDMI won't. So a lot of it is about sort of choosing what you route first and then having a kind of structure in your head of which layer everything sits on. And then not being afraid to occasionally move and shove stuff around to make it work better.
Yeah. I caused a little bit of chaos by adding a few components onto the board at the very last minute, and there were some change control issues where you lost all of your component assignments. Let's not talk too much about that, but I guess it's on video now. But like when I was adding those things, I'm often finding myself doing these 3D or at least 2D geometry problems in my head where I'm like, I've got a route of pins here and it needs to go to this device here, they're in this order here. So if I flip that one there and that one goes there, just choosing which way you route them. And it's like this geometry problem you
Mm.
have to do in your head. Um, uh, it's weird that auto routers haven't got there. Um,
Yeah,
yeah.
I sort of think it's the next frontier in AI in some ways. And I mean, auto reading has been a problem that it's odd actually. I don't know why auto routing isn't a thing because when you're doing chip design, if you're
Mm,
actually designing the silicon, that's none of that's routed by hand. That's all
yeah.
auto routed. So all of the actual silicon on your processors and stuff. I mean, no one would dream of doing that by hand. You kind of design everything in a hardware description language, and then you've got these kind of fancy genetic algorithms that synthesize where the actual bits of silicon gates need to go. And people were using auto routers back in the kind of 80s and stuff,
Mm.
when boards were a lot simpler. And then I think just the tech never caught up. It is a very multivariate problem, so you can't really solve it very easily with traditional approaches. You become the main problem here is that the layout and the placement and the routing are two different things. So one of them
Yeah.
is where the actual components go, and the other one is how do you connect them together. And in some ways, the placement is the harder of the two problems, because some of them are hard constraints, like your connectors have to go at a particular place on the back of the board or the front of the
Hmm.
board, or maybe they don't. Maybe actually, it's going to be nicer to move this connector to the other side. Is that okay with the mechanical designer? Does that look sensible? Et cetera, et cetera. Are there going to be collisions between them? And then there are some parts which have a lot more flexibility as to where they go. Decoupling capacitors can go pretty much anywhere on a board. And your test points for JTAG or whatever can
Mm.
go pretty much anywhere on a board. And so I think the first thing there is like, it's a kind of very iterative process where you try and place everything where you think it's going to go before you route it.
Mm.
And then you route it and you realize, this isn't quite right. Actually, I wonder whether this is going to be so much nicer if I could pick a slightly larger resistor here and then I could route a trace underneath it. I wonder if
Mm.
there's a resistor here that fits. Okay, oh yeah, there is one in stock. So let's move that one up to an 0805 and then trace can go through it so it doesn't have to go through a via back and
Mm.
forth. So there's just so many kind of the edge cases occur all the time, and a lot of it is kind of this weird judgment of like, well, this signal is more important than that signal, and that signal actually is not that important, but it is very low noise. This needs to be routed far away from other ones, and et cetera, et cetera. And then you get to a point, you have to think about the manufacturability of it, where if you have too much copper on one layer and you have not enough copper on the opposing layer in the stack, the board can warp. So then you're thinking about, where you fill your planes. You don't want large bits of copper unconnected to things because they act like antennas. There's so many kind of trade-offs that you're making, which has made it, I think, quite a bad fit for traditional, algorithms that are kind of quite designed to kind of numerically solve these
Yep.
things. But what I think AI with a kind of heuristics based, vibe based, yeah, this component looks like it should fit here. Is probably going to be quite a good fit. So I'm looking forward to our AI overlords.
I think the thing that's missing to inform like auto routing is a good description language, or even if the description language was there, but it's a pain in the ass. Say, this is a high-speed digital signal line. I care about this one a lot. This is my priority number one line. This is priority five. I think where AI might be helpful is, okay, this is going from a DDR4 chip to an FPGA. It's probably high speed. It's probably important. It probably needs to be, routed in a certain way. I think it'll be interesting to see where we get to. I think um, it's amazing. Like I think you're the one to blame for my journey onto AI, and as well for Luke. I think you mentioned in our group chat, well, like, hey, you should check out this Chat GPT thing. And both Luke and I, being old school C programmers, were like, oh, no, no, that's not the way to do things. And now I think we're both addicted. We both have
Yeah,
problems.
truly. Yeah, I
Um,
mean, it's funny, it's ironic there because I think I was, in a lot of ways, the biggest advocate for AI tooling and software. But now
right.
I very rarely use AI for anything in the electronics world,
Yep.
weirdly. I mean, it's sort of good sometimes for finding parts. The problem with it is that it comes up with a lot of old common parts.
Mm,
If you go, oh, I'm looking for an ADC to digitize video, it's got to have these specs. It'll probably do something that it's found from ages ago that plenty of people have used and not show you the new part
right.
that is quite rare and quite niche, but is a bit better. It has a habit of suggesting op amps from the 1980s. It loves a, TL07 or whatever because
Right.
everyone's used it. And they're,
Right.
they're terrible. But in every way, there's better alternatives. But ChatGPT likes suggesting um, parts that it's used to, and it does the same thing in the software world, where it kind of recommends software libraries that everyone uses and whatever. Um, so yeah, I mean, ironically, it's not something I end up using a lot.
There's probably been enough videos of white dudes talking about AI, so maybe we'll put a pin in that part of the conversation. Um, into more exciting stuff. What's the next personal project for you? What are you excited to be getting onto next after you're wrapped up with this?
I'm looking to launch a bunch of products in the audio world. I mean, one thing is the Wayfield stuff, which I think
Yep.
I'm excited to launch. And I think
And that's a fully open
that's the
source
kind of
hardware software project.
yeah. There's a bunch of we're trying to figure out what's going to be open source
Right.
for the moment. You know, that's kind of the passion project, the weird art world
Yep.
project. That's kind of that's the hobby project, really.
Yep.
It's not a money maker. In the kind of the thing that I've been thinking about for a long time is just a bunch of tools in the audio world to make nuts and bolts a lot easier. And it's weird because it's a similar thing to what SCION's doing for the video world,
Mm.
is that there's not quite the right ways of doing analog to digital with time sensitive networking, where Luke and I have been working on this audio protocol called AVB,
Hmm.
which is a IEEE standard for you know, time sensitive networking and getting audio to arrive deterministically. And it's a cool protocol, but basically no one has made enough hardware that works with it. So I'm making some niche boxes that will convert audio to network and back have a nice form factor that can be dropped on the floor and won't break and all of the sort of useful things.
And this is going to
So
replace a
yeah.
bunch of snakes on stages.
Yeah, exactly. We're still use snakes on stages. You know, people are still using, you know, big multi-cores on the stage for the
Mm.
last hop,
Right.
because the configuration thing is annoying. You know, trying to figure out which of your devices is working or not. There aren't the right kind of troubleshooting LEDs and lights on the front, and it's all of those little fine details that I think people don't realize make a really big difference to a product. There's tons and tons of products that kind of technically do a thing, but it's like, oh, there's there's some like software that you need to use to configure the thing, and the dip switches don't actually reflect what's on the right thing, or the LEDs are really dim on this, so you can't see it in daylight, and all of our
Hmm.
shows are in daylight, so it doesn't work. Or, you know, sometimes the opposite problem, the LEDs are so bright that it's really annoying to use in a rack on stage because it lights you up like a floodlight. There's all sorts of kind of
So
tiny
you're going
little
to make
things.
LED brightness controllable over Ethernet.
Yeah, I mean, yeah, I think isn't that an option? You've got that on
Yeah.
your OSC protocol, haven't you? You've
Yeah,
got run
probably.
LED brightness.
Yeah.
We've got the
No, I
options.
don't now, but now you've given me another feature idea.
Yeah,
So
I mean, it's supported in hardware, so
yeah.
you heard it here.
Yeah. Where can people find more about your stuff?
I am on my website on maxhunter.me, which is woefully out of date, but has a bit of a selection of the things that I'm working on.
Awesome. This has been a wonderful 10-minute conversation that has gone over budget by a few minutes.
RIP
Um,
your hard drive.
no, that's great. It's been really fascinating chatting with you. Thanks again, Max, for like working on this project. This has been a passion project of mine for a while that I really couldn't have brought into reality without you, and it's been a pleasure working with you. So thanks for taking the time to chat, and hopefully you'll be able to dust your hands off this project soon and get onto more fascinating stuff in the audio world.
Likewise, yeah, it's been a pleasure working with you, and I look forward to having it in my hands.
Me too. All right. Keep well,
All
Max.
right.
See ya.
Bye bye.
Bye.